Hi, my instructor name is Gautam. My name is David Krishna Reddy. This is my ID. Today we'll be discussing about the hash tables. Here we are checking how can we improve the time completion order of and to order of login. And the technique we apply from hash table is called hashing. And here the time complexity is one. Here the first time complexity is order of n. Let's jump into the direct access tables. Direct tables are exactly same like an array. It operates as an array. It maps corresponding key values, and for example, it can set like a key one value one, key to the value two, key and to the value, and same thing. Address indices are represented as an array. For here example, the number of keys and array, table hash table. And for example, for an array, if we want an array we want a value of 5, it can be of 4 in array. And in if we want in DAT, direct access table, the value of key of 7 can we can get a value of a of 7. This is the difference. And yeah, here the time complexity is order of first time complexity of order of 1. Disadvantage follow the same as an array. And yeah, advantage is this search time is order of 1. Disadvantage is we should know the prior maximum key values. Otherwise, we cannot create a dat value if we don't know the maximum key value. In the same way, we can particularly possible if max value is less. So this is the example. So how do we do it? Because it creates a lot of space wastage. Hash table is now let's try to overcome this disadvantage of that using the that techniques. It maps to the hashing is it maps the key values into the hash tables using a hash function. Let's see this hash functions. So hash function is basically a function which will take your particular key and input and does it the same operation in the hash function and implement it, and then will give you a hash index, and particular hash index will go to the place in a key. For example, here we have the keys, number of keys, and this is the function, and this is the tables. So if we see here 21 modulus of 10, 21 modulus of 10 equal to 1. So the value is placed in the 21. This is how it works. So if there is a collision, how we fix it? Collision occur when multiple keys are the same trying to map to the same function. So if we see here in this example, 21 modulus of 10, 31 modulus of 10, everything is like value 1. So it is getting collision here multiple times, and it is getting replaced by 61. So how do we fix it? There are three famous techniques: good hash function, chaining, and open addressing. For good hash function, number of collisions should be less, key should be distributed uniformly in an array. Best results are from hash table size should be prime. For the chaining, chaining occurs as good result, and chaining as a concept array of pointers and array of linked list. So loud factor is alpha equal to n by m. Advantage of chaining is simple implementation, dynamic size, efficient large size. Disadvantage is additional space pointers. Open pointers and closed or closed hashing. All the implements stored in the hash table itself. Linear probing, quadratic probing. So let's discuss about the linear probing. Linear probing has two functions, and we have the probe hash linearly. So let's discuss. We have the key and we have the size hash table size and number of function one and function two. So what exactly happens is here at 21 modulus of 10 equal to 2, so we'll place the value here, and 18 modulus of will be keep on doing. Here we face an encounter here. 21 modulus of 10, 2 modulus of 10 equal to 2. So here we have faced a collision. So how do we fix it? Is pick the h of x, that is the first value, the index of it, and we get the index of 2. So 2 plus collision of first number, and the collision of first number 2 plus 1, and modulus of 10 that equal to 3. Again we had a collision. Now again we have to do the second collision. 2 plus second collision number that equal to 4 modulus of 10 that we will use. Then 4 is 4 modulus of 4 equal to 0. The value is 4, that is empty. Then you use that. The same way we use it, and we keep on doing it. That's why we call it the linear collision. Disadvantages suffer from lots of primary clustering, and such time is this one. And quadratic problem is the same as the linear problem, but here we do is 1 square, 2 square, 3 square in the same function. If we do here, if we face the collision here, number if we do the same way. 6 plus 1 square equal to mod 10. And already we have the collision. Again we will do the 6 plus second number, that is 10 model of 10, that is equal to 0. We have a value empty here, and we do the advantages is no primary clustering, no guarantee, secondary clustering, and such a fun. So yeah, thank you.